Hello everyone. Let's start discussion about the storage system management and components. So why is storage system important? That's the first question that rises in most of our mind, right? If it's not important, then waste why to bother wasting our time and efforts in learning about them? So let's first understand why it is important before we jump into the details of what is it and intricacies of how does it work. First, to understand it's important, let's imagine what happens if you cannot remember. Let's say if you have a day and then next morning when you wake up, you cannot remember whatever you did yesterday. If our life was like that, how exciting would that be? Would that be exciting? Probably we would end up, we would spend whole our life just living the same day again and again and again and again, right? So not that exciting. But now apply the same analogy to computer devices, and computer devices that doesn't know how to store and access data, it's pretty much the same because then it doesn't know how to remember. Thus, any devices without access to data or without knowing how to access the data, it's pretty much a useless box. Computer devices, as well as most of our recent technologies like uh, email servers, browsing web, if you're watching video, playing games, anything that you are doing, in you would be accessing data. So in all these operations, there is a stream of zeros and ones that's being either um, downloaded or uploaded. And that shows the critical importance of data. Now, making it more simple, let's imagine a program without input or output. Can you write such a program without input and output? I'm sure you can. Probably that was the first program that most of us wrote back in our school days when we were first introduced to computer system. Hello World program, right? That does not have any input, does not have any output. Now, well, even that's critical. Hello World program, if you are printing Hello World, then it does have output. So sorry, I take my statement back that it does not have any output. But you could come up with a program that does not have any input independently of a program that does not have any output. So two separate programs. But now let's think, will this program be useful, or can you make a program without an input or output to do any purposeful task? Here comes the challenge, right? So we'll give it a moment for you all to think about it. If you can write a program without an input and output and ensure that program is doing something useful or purposeful task. Okay, most of you would have been exhausted with the thoughts, but couldn't come up with a program. Same as me, right? Even I tried, but I could not. And that leads our thought to the fact back again, how much input and output is critical for a program. For any computer program to do anything useful, it needs to have some input. So it knows what is it, what's the state that it's starting its process from. Probably it's not starting its process from the scratch. Every call of execution. So those are the input variables and its state. And then during the execution of the program, we perform some analytical operations, some tasks. Some programs are quick and short. Some programs are complicated that runs over days, over months. Some high performance computing task also runs over years. So now Each of these programs, after their execution is completed, needs to show the progress or needs to report what it did during its execution, right? That's output. Even a simplest hello world program has an output, which is printing an hello world statement either in the file or on the console or somewhere. So probably if you don't have an output, then what's the purpose of the program itself, right? So most of the programs have input and output, and if you have input and output, you need storage system to handle this input and output. So I hope I've convinced you that storage systems are important. Now, another important question is, what makes them so cool? So cool that today we are studying about them as a course, right? So in this lecture, what makes them so cool? Well, to start with, I would say that it is combination of many hot topics today, or hot areas today. This is where great jobs lie if you are interested to join industry after you graduate. Because if companies don't figure out how to manage and make sense out of their data in an efficient way, probably the company would no longer exist. So if you are master of how to manage and make sense out of data, basically master of storage systems, then companies will always need you. And irrespective of a designing field or an implementation field, they would need experts in storage systems, experts in people who know how to manage and make sense out of data. Continuous growth in these areas or continuous growth of digital technologies by digital technologies, I mean anything that's stored into system or anything that we store as a stream of zeros and ones and then make sense out of it. Ensures that there is growth in the, or there is scope of even more research and engineering in the field of storage systems. Now, let's say if you're not interested in joining industry after you graduate, even then, maybe you want to start your own enterprise, start your own startup. Storage systems is a great area for you to consider and think of in handling, in designing a solution which solves the problem of managing and making sense of data. So it's a great area for new startups. And let's say if you're not interested in industry after you graduate, you're not interested in startup after you graduate, but you are someone like me here in this room, or who is interested in pursuing PhD, or who is already pursuing PhD. Once upon a time, a decade back, I was in the same shoes where I was doing my master's and then I was deciding what to do next. I decided to go with pursuing my PhD, and hence I stand before you as a professor today. So let's say even you have a similar career path like mine. So in that case, if you want to do PhD, then the question is, what would you do research on? Because PhD is all about coming up with new knowledge, right? So is storage system a good enough area to invent new things? Well, yes. it is, we have still so much room to improve. So it's a great area even to do your thesis on, to pursue your PhD on. And all this is because performance actually matters. So we might have a traditional way of getting the job done, but that traditional way may no longer be the best way to get the job done. With invention of new technologies, emerging devices, and thus with every new device or every new technology, there comes new challenge of how do you use that device to its best. And if we figure out how to use all the devices that are at our disposal to its best, that's probably an optimized performance. But right there, the problem is not yet solved. So optimizing performance, capacity, reliability, and many more. There are so many things yet to do in this field of storage system, although it is a very, very old and well-studied field. Thus, this is what makes this storage systems topic so cool. Now, if you all are on the same page with me and you agree that storage system is important and you have a clear picture in your mind, why is it so cool? Then let's proceed with our lecture to spend the rest of our minutes in understanding storage system management and components, and have a lot of fun while understanding that. So what are storage systems all about? When you talk of storage systems or memory systems or memory and storage systems, it's all about hierarchy. So basically, it's combining many technologies to balance performance, capacity utilization, costs, anything else, reliability. Because you don't want your data to be just gone one day, right? That would be a disaster in today's world. If we lose our data, that's the biggest nightmare. Sometimes, let's say if you're not finding your phone or laptop, rather than the thought of losing your physical device or physical phone, or you would have to buy another one, the thought of losing the data that existed on that phone, that scares you the most, right? So reliability is also important. So combining many technologies to have this sweet balance or trade-off between different quantities like performance, capacity utilization, cost, reliability. That's what constructs this hierarchy. And when we are dealing with storage systems, a very important property of storage systems is persistence. So we want to store data for a long period of time, or at least the period of time until which we might anticipate that we would have any other future use for this data. we want to organize the data. So data organization, so that we find it. Let's say you have thousands of clothes, but you don't know where are they. So how juggled your mornings would be, right? Finding different, like finding what you would wear today. In the same way, if you have a lot of data, but you don't know where the data is, no point of having that lot of data. So data needs to be organized in a fashion that you know where what things is stored. It needs to be consistent. Let's say if you read the data at one location, first time you get something. Let's say that's a color red. Now you read the data at the same location, second time, you should get color red again, right? Because that's what the consistency means. If doing the same operation over and over again in time, if you get different results, then it's not consistent with itself. So when we are talking about the data, the access is being consistent is implies implied. That's very critical that sometimes we don't even think of that. And things like data corruption. Now, we could have a storage system where we know where exactly what data is stored, so excellently organized. The data that we are storing is able to stay there for a long time, so it's persistent. Every time we access the data, it gives us exactly what we are looking for again and again. So it's consistent. But over a period of time, if the data is corrupted, either because of some hardware or mechanical failures, or because of external implicit corruptions, which such something as somebody hacked into your system and erased all the data that you have. So handling such issues of data corruption is also important because this data that we are maintaining needs to have this persistence guarantees. So this gives us an idea about what our storage systems all about, hierarchies, and how hierarchies are important. What are things that we need to think of when we are talking about storage systems?